For this computer assignment, we're going to be using a new data set, and the data set was shared with me is one that has interview data that was collected from adolescent African American males. And I'll go over and show you the data in just a second, but just to give you a sense of what it looks like, there's demographic information, there's information about how important school is to them, how far they'd like to go in school. There's questions about how important religion is to them, how often they attend religious services. And then after you get through some of this demographic information, then you start to have some questionnaires. So there's questionnaires that give us data on self-esteem, questionnaires that give us data on stress, various things like that. So the questions that we're going to go through then are going to be questions that require one-way analysis of variance, two-way analysis of variance, simple regression, and of course both between and within repeated measures. And the data file has this name, and so you should be able to I've made that accessible to you. So one other thing you need to know is that the data was collected at baseline, and all of the variables that were collected at baseline are identified with this .1 at the end of the variable name. They were then collected after a 4-month intervention, which is identified by the .2 at the end. And so if I come over here where you can see the SPSS file, these things don't have a dot. That's because they only asked that question once. But here we get over to the testing date at baseline. Oops, I went too far. Here's whether or not they think sex is okay for teenagers at time 1, whether their mother thinks sex is okay for teenagers at time 1, their outcome expectancies, if they think they can say no, etc. And then when you come out here further to the right, you find the same variables at the second time point, which is after the intervention. And then if you keep going, you can see with the .3 that they have the same variables 1 year later at a 1-year follow-up, 1 year after baseline, and then also 2 years after baseline. Okay, and for the intervention, participants were randomly assigned to be in one of 3 groups, and that's identified in the SPSS file by this variable that cleverly enough is called group, okay, that has 3 levels. And so what we're going to do then is we're just going to answer some questions regarding the data. And I tried to provide a little bit of background here so that you'd understand, like, why are we asking these questions? So if you read this paragraph, basically I'm arguing that one thing we often want to know is if we randomly assign people to groups, okay, that's great, but random assignment doesn't always work perfectly. So if there are things that we need to be equal between the groups, then we may want to actually check and make sure that they are equal. So say that we wanted to find if there were differences in age, that's the dependent variable, as a function of group, and then at baseline is just telling us which age variable should we use. So we come over here, and to do our one-way analysis of variance, it's under Analyze. There are actually 2 places where you can do one-way analysis of variance, but I'm going to just use one of those options for now. And it's under this general linear model, and then you come to univariate. And univariate here means you only have one dependent variable. Now that dependent variable could have been measured at different times, but there's only one variable. In this case, it's age at time 1. We won't be doing multivariate. That's a completely different class. Multivariate analysis of variance is when you have multiple measures of dependent variables that are meant to assess kind of similar constructs. And we will be doing repeated measures. This is where we'll be going for our one-way within subjects designs. But for right now, we're doing the univariate. So we click univariate. And the dependent variable, that's easy to understand. You're going to put in age there. But then you have choices about whether you think your independent variable is a fixed factor or a random factor. And in all the work that I've done, we've always considered it to be a fixed factor. And a fixed factor means that you basically think that you're not taking a random sample of levels of the independent variable. You think you have all of the levels of the independent variable that are relevant to the research question. So that might be difficult to understand, but if you can just remember to always put it in as a fixed factor, that would be great. And then there are a couple options you want to choose here. So one thing, we have 3 groups, so if there is a significant difference, we'll need a post hoc. So we go ahead and say that we would like a post hoc for group. And the one that I usually choose is this 2 keys test right here. So you click continue. And then you also will want to see what the actual means are for your levels of your independent variable. So you take group, pick up group there, and shoot that over so you'll get means for it. And then lastly, because most journals now require you to present measures of effect size when you make your conclusion statements, you can also click that right here under estimates of effect size. I haven't gotten you guys totally in the habit of writing those in because we haven't learned how to calculate them by hand, but it'll be good for you to click that here so you can see what those look like. So you click continue, And then, as always, I'd like you to click paste, so you kind of save that syntax, and then you run it. And you go ahead and run it from here. You highlight it and hit the green button. Okay. Now this is the data that you're going to see, and you can see up here that it's telling you that you've got 3 levels of group, and it tells you what the sample size was in each of those levels. This, of course, is the box that tells us the results of our tests of between subjects effects. And what's tricky here is that you have to come down in this column until you find the group factor, which is the one that you asked for. Here's its degrees of freedom. Here's mean squares, which you're used to looking at. Here's here's sums of squares. Here's the significance, right? And then the other information that you'll need, if it was to look like a source table like we're used to looking at, would be these 3 things right here. These 3 rows of data right here. So I'm going to go ahead and highlight those in yellow so that you can see them. And this is what I'd like you to do on your homework assignments too, so I know you're looking in the right place. And then we also get, this is the measure of effect size, and so I'll just highlight that in a different color so you can see it. See where that comes there. So what we're looking for, of course, is significance. And the question is the significance that was observed, or the significance level that matches with this F value, is that less than 0.05? And clearly, since it's 0.003, it's much less than 0.05, which means that group does have a significant effect on age, and that there are differences between the levels of the independent variable. And again, you can see up here, here's the sums of squares. If you divide 14.44 by 2, that gives you the mean square. Here's the sums of squares related to error, and you can see that's a huge number, but it also has a huge degrees of freedom. So the denominator, the mean square, actually comes out kind of small. And then this 7.22 over the 1.26 gives you the 5.74, and then the computer tells you precisely what the likelihood or probability of that large an F is. Okay, so what we would need to do then is that we would need to write out right here our results for that. And so that you guys aren't just watching me type, I'm just going to paste that in so that you can see it. So you would type something to this effect. There are significant differences in age as a function of group. F with 2 and 520 degrees of freedom equals 5.74, P less than, and I just went ahead and put 0.01. Now we do need another sentence that tells us, okay, what was different from what, and we get that down here. This estimated marginal means, that's giving us the actual means and standard error for each group. And then down here is where we see the post hoc tests for group. And so what you have to look at here is where there is a star. So this is a little bit tricky to interpret, but they're comparing the control group to the life skills group and the social cognitive theory group. Then they can compare life skills to control and social cognitive. Then they compare social cognitive to control and life skills. So they do all the comparisons. There's kind of some repetition here. When we did it in a box and I said you only have to do the upper or the lower, above or below the diagonal, well, they give us both. So what you see here is you look for places where there's a star, and this is telling you that this mean difference between I, the control group, and J, the life skills group, is 0.41, and that is significant. So we know that that's a significant difference. Then we look, and the only other one is actually the same one because it says 0.1 for the control group versus the life skills group. So that's the only significant difference that we get. So now all that we need to do is we need to just add that sentence over here, which you can say I've already done, that says that participants in the control group were significantly younger than participants in the life skills group. Okay, so that's not a good thing. That's not ideal. We would have liked the groups to come out and be non-significantly different. So that's something that the researchers would have to consider in terms of how they choose to interpret their data. Or if they want to use age maybe as a covariate to control for differences in age between the groups. Okay, so then let's look at this next question, which is, okay, also at baseline, are there differences in participants' views about whether or not having sex as a teenager is acceptable? And this variable is called sexok.1 as a function of group. Okay, so we're going to come back over here to our data set. We'll go to Analyze again. We're going to go to Univariate again, right? And we already have group in as a fixed factor, so we're really all that we need to do is we need to switch age out, and we're looking for this variable that's called sexok.1. All right, and I'm going to put that in here. All right, it should remember the various things that we've already selected, and those are all still okay, that we want the 2 keys post hoc if there are differences. So we're going to paste this into our syntax. Then we'll go into our syntax window and run this analysis. Okay, so hopefully this looks a little bit more familiar to you now. You see that we're developing this kind of an outline of what we've done. This is the univariate analysis. It shows roughly similar numbers here. They might be a little different if they're missing data for anybody. We come to this test of between subjects effects. We're going to look for a group, and then of course we need error for our term in the denominator and total. And we need all of these columns of data. We need the mean squares, the F, the significance. And that is what we are looking at then to write out and draw our conclusion. That's the data that actually looks exactly like the source tables that you all have gotten comfortable with. Partial eta squared, I should have said on the last one that a bigger number is better. And so this is obviously really small, which matches with the fact that this is a non-significant difference. Let me point that out to you here. So the significance for this group effect on whether or not they view sex as a teenager is okay is non-significant because that's substantially bigger than 0.05. So all we need to do then is we need to write that then in to our results in the assignment. Okay, so we're just going to type that in here. Here we're going to say that there are not significant difference in participants' views about whether or not having sex as a teenager is acceptable as a function of group. That's the independent variable. We put our F with 2 and 511 degrees of freedom, and that value is 0.40, and that is a p greater than 0.05. And then we don't even have to look at the post hocs because we knew that it's non-significant difference overall. And you can see when you look here that the means are very similar. Okay, so let's move on then. What the assignment suggests now is, okay, now we know that randomization was effective. So what we might want to know is if any of the interventions were effective. We might want to know if there were differences in the change from baseline to post-intervention to follow-up 1 to follow-up 2 as a function of group that people were assigned to, okay? And this would actually be a mixed two-way analysis of variance, and it's mixed because you have one between subjects factor group and you have one within subjects factor time. We haven't learned how to do that, okay? So instead, just for the purposes of this assignment, this isn't how you do it in real life, but for this assignment, we're just going to look at this question for the three groups separately. And so to do that, you're going to come over here and you're going to go to data, and you're going to split the file. And you're going to split the file based upon group so that we get the output organized by group, okay? And it's really important to paste that, of course, so that you remember that you're doing it for the three groups separately, okay? After that, what we're going to need to do is we're going to want to do an analysis where we look at, now I've forgotten what the variable was. We're going to look at, because I didn't say it yet. For this question, we're going to look at whether or not there are changes in their views of whether having sex as a teenager is acceptable over time. So from time 1 to time 2, that would be in response to the intervention, and then time 3 to time 4, that would tell us if it kind of wore off over time. And so you've got 3 questions to ask here, one for the control group, one for the SCT group, and then one for the LSK group, the life skills group. Like I said, normally you wouldn't do it this way, but we're going to split the file, and then once we split the file, we're going to do a repeated measures analysis of variance. You can name the independent variable anything you want. In the question, I suggest maybe you name it time, and it's got 4 levels because you've got baseline, post-intervention, 1-year and 2-year follow-ups. So you add that there, and then you click define, and then here's where it's waiting for you to put in your 4 different measures based on the 4 different levels of time. And so it's a little bit tricky to find these in here. Here's sex okay at time 1, come down a little bit further, sex okay at time 2, down a bit further, sex okay at time 3, and sex okay. Where are you? There it is. Sex okay at time 4. Okay. We don't have any between subjects factors again because we haven't learned how to do that in class. If you were doing it for real, this is where you would put group. Okay, so that you could do a 2-time by group analysis of variance. You'll see here when you go to a post hoc, you can't select post hocs for repeated measures variables at SPSS. I'm not sure why that is, but you can sort of trick it by coming over here and asking for the means for time, and then you can say compare main effects, and you can choose to do one of these post hoc tests. We'll just do Bonferroni. That'll actually do a post hoc for repeated measures, even though SPSS doesn't for some reason want to let you do that. And then we can do estimates of effect size here as well. We hit continue, we hit paste, Now we'll go over to our SPSS syntax window. Make sure you highlight this first, otherwise you're going to get it for the whole group, not for the 3 groups separately, not for the 3 treatment conditions separately. So we do this, we run it. If you go back to the data window, it tells you there that it's been split by group, okay? And so you come here, and what it's going to give you then is 3 separate repeated measures ANOVAs. The first one's for the control group. When I scroll down, I get the one for the ones for the other 2 groups, okay? With repeated measures ANOVA, you always just ignore this multivariate test, all right? So just ignore that. You do need to look at this, although I'm not going to make you do it for the assignment, but in case you end up doing this like in your dissertation, this is essentially a test of homogeneity of variance. That's what it works like we did in an independent samples t-test. You want this to be non-significant. If it's non-significant, then you can just ignore it. If it's significant, then when you get down to these effects where you're looking, you would actually do some sort of an adjustment because if it's significant. But for the purposes of this, the assignment you do for me, we're just going to always assume sphericity. We'll assume this was non-significant. And so what we'll be reporting then, and I know this is tricky, so it's got time and it's got these 4 different ones, but we're just using the top one. Then it's got error and it has 4, but we're just using the bottom one. So you're going to do these are the variables that you would, sorry, I keep forgetting to do those. These are the variables that would make up your source table, just so it looks like what you guys are used to seeing, okay? But where we're going to actually look, of course, is in this column to see if it's significant or not. And what we find out is that there is a significant change in subjects' views on whether or not having sex as a teenager is okay for this group, okay? So this is where you always look for repeated measures, the test of within subjects effects. You skip this one. We didn't have a between subjects effect. Here are the means I asked it to give me. And here are the pairwise comparisons. And these pairwise comparisons, when you look in here, you can see that here's my star, which is telling me, get this out of the way, it's telling me that their views at time 4 were significantly different than their views at time 3. And this just tells me that same information. Okay. So the first thing that we'd write is we would just write what the conclusion said, right? So we would say that there is a significant change in participants' views on whether or not having sex as a teenager is acceptable as a function of time. We put the F, it's back up here, with 3 and 495 degrees of freedom equals 3.12, p less than 0.05. Then we need to add a sentence that tells us sort of, okay, what's happening, and that's based on the post hoc findings. All right, so the post hoc findings tell us that views stay pretty much stable in response to the intervention. So if you look at these means, right, you're looking at these means here, you can see that it stays stable in response to the intervention, which you would expect, right, because it's the control group. But then, and they also stay stable to the 1-year follow-up. But then they increase, sorry, I wrote that the wrong way, increase significantly at the 2-year follow-up. So probably that just means in response to getting older, they're starting to think that it's more acceptable to have sex as a teenager. Okay, so now when we scroll down here, we're going to see the same type of analysis for the life skills group. All right, so again, you skip this. You look here to see sphericity. Here's one where it is significant. And so what you would do in real life is that you would actually look down here and do one of these adjustments depending on what was recommended. And you would report these funny degrees of freedom that have this decimal point. Okay, again, I'm not going to ask you to do that for the purposes of the class, but that is what you would need to do when you were presenting your results from your dissertation, in this case, because it was significant. Let me just highlight this for you so that you have it. If you ever want to come back and look at this going forward, I'll put that in red. So you can see that because that's red, then what that means is that for your real, I said I wasn't going to have you do this, but that you would just be reporting. And the only thing that's different, look, the F values don't change. Nothing really changes, but you let it, but it will sometime. It doesn't in this case, but sometimes it will change. But you would actually report degrees of freedom 1.02, comma 161.75. Okay. But for this class, we're just going to assume sphericity, and so you'd be reporting that for this group with 3 and 477 degrees of freedom. Here's your significance. This is the data that you need for your statement. So we would just write that in here then for this group. Okay, so what I want to do now is I want to let you do this one on your own, and I'll leave a place that you can check this. I'll post it somewhere so you can find it, so that you can make sure that you're actually understanding how to do that. And I'm not going to ask you that question. Okay, so this will give you a way to check that you're getting it for the third group, the LSK group. Oh gosh, I'm so sorry. These are mixed up. Okay, this is actually the LSK group. I apologize. They're in a different order than I was expecting. So this conclusion was actually for LSK. All right, but the one down below this is the SCT. Let me show you. The one down below this is for SCT. So you can answer it for the SCT group, and that'll give you a chance to practice on that. Okay? All right, so now let's see if there are, we know that really that they haven't changed much over time, but maybe the groups are different from one another after the intervention. So let's just use a one-way analysis of variance to find out if at the post-intervention there are any differences in views, that is the sex OK variable at the post-intervention as a function of group. Okay, so you've already, you know what, actually I'll let you do this one on your own too, because you've already done this. We've already done a one-way analysis of variance, one-way between subjects analysis of variance. So let me let you check your work on that one too. All right, and that'll give you a good way to know you're getting the hang of this. Okay. This is the same thing. I'll let you check your work. You guys are getting tired of listening to me anyway. This YouTube video is getting too long. Okay. You know what I mean. I'm going to stop here.